Hey guys, we're going to be jumping into chapter 5 here. This is going to be kind of a lengthy lesson, so make sure that you have some time blocked out for this. You're taking good notes, and we'll keep moving. So make sure you pause, copy down these vocab words. Rate of change shows the relationship between two changing quantities, and you'll want to write this down right here. Change in the dependent variable over the independent variable. And, you know, you guys talk about these kind of things in science. This is the one that changes depending upon whatever happens here, and this will make a little bit more sense when we look at a couple examples. So it says the table shows the distance a band marches over time. Is the rate of change in distance with respect to time constant? What does the rate of change represent? So first thing we got to do is figure out what happens here. As time increases, it is increasing by a minute every single time. Okay, so that's a constant increase. Now over here, how is it increasing? It is increasing by, it looks like, 260. Whoops, move my screen there. 260. What's the difference between these two? It's 260. And here, 260. So my dependent variable is the distance, and my independent variable is the time. All right, and I write these two things, and I find the change in distance over the change in time. That's what that other slide was. So I'm going to have the change in distance, or the difference. So I have the difference, or the change in distance, over the change in time. And we'll talk more about how this sets up in a little bit, but the way these two things shake out is I get a difference of 260. Okay, so what does the rate of change represent? It means they go 260 feet more per minute. That's all it is. Don't overcomplicate this. This isn't super difficult. So it's 260 feet per 1 minute. And that's the rate of change on that particular one. Here's one for you to try. Go ahead and pause. And I'll give the answer in a second. 3, 2, 1. All right, so that's what I got. This is kind of a weird you try question, but on the example before, we used these two. For this, I just used these two, which means I also need to use these two. And when you simplify things out, you still get 260 feet per minute. So if you didn't get that, you did something wrong somewhere. Go back and find it. All right, so yeah, I'm into fitness. This is kind of my workout mantra, how I like to do things here. Yeah, I'm into fitness. Fitness whole pizza in my mouth. Bam! All right, so slope. Need to write this down. We're going to have multiple representations of slope. So the first thing is slope is the vertical change over the horizontal change, how something changes up and down over how it changes left to right, which is a change in y over the change in x. If you think of this in the coordinate plane, the y value tells you up and down, the x value tells you left to right, which we call rise over run. Okay, so make sure you have all three of these copied into your notebooks. And here is how you would find the slope using a graph. You just find points on the graph where it crosses the grid perfectly, and you literally count. You do your rise first, so this one goes up 2 units, so it's up 2, and then it goes to the right 3, so it's the rise of 2 over a run of 3. That's the slope. This is called a slope triangle. Very, very simple. Here, if I do my rise first, it goes down, and anytime you're going down, you're going to say that that's a negative. So I have negative 4, and then it goes to the right 1, 2, 3, 4, 5 units. So I have negative 4 over 5. Always do that vertical change first. Now, one of the things that I get students doing often is they look for these points, and if it doesn't have a point, they freak out. Don't freak out. You find where it crosses the grid perfectly, and you make your own points. All right, here's one for you to try. Go ahead and pause, and the answer will be up in 3, 2, 1. All right, so here you go. This one is 2/5, and this one is negative 1/3. If you did rise over run, you would have got negative 2 over 6, but you always simplify this. Make sure that you are simplifying. Let's keep moving here. So more on slope. Make sure that you pause and write this down. This is the formula for this. Is very, very important. The x-coordinate you use first in the denominator must belong to the same ordered pair as the y-coordinate you use in the numerator. That's what these subscripts mean. Okay, so if I have 1 point, I have 2 points. So I have x1 and then y1. So there's one ordered pair. My other ordered pair would be x2, y2. And what this is saying is that if I use the y value from this one first, then I have to use the x value from this one first. All right, I could use this one and it will still give me the same thing. So that's what we are, that's what this is talking about. All this means is just make sure that your order is the same. How does this play out? Well, it says, what is the slope through the line -1, 0, and 3, -2? Well, I take the difference in y, so I do this one minus this one. And I put that over the difference in x. So 3 minus -1. Now, before I go through and solve this, notice that I used a -2 first for my first y. That means I have to use 3 as my first x. You could switch this around and you'd get the same order. I could do 0 minus -2 over -1 minus 3, and it still comes out to be the same. I just did it this way this time. So -2 minus 0 is -2. This, I kill subtraction, and I get 4. And this simplifies to -1/2. All right, so that's all you do to find slope using 2 points. It's the difference in y's over the difference in x's. Here's one for you to try. Go ahead and pause. The answer will be up in 3, 2, 1. All right, there's your slope for this. It's a negative. Notice that it's 4/3, and I did not change it to a mixed number. Leave your slopes as improper fractions. Always simplify them if you can, but leave them as an improper fraction. All right, finding slopes of horizontal and vertical lines. What is the slope? Well, if I try to do the slope triangle on this, the rise is, well, I don't ever really rise, right? So I'd say that's a rise of 0 over, and then I go, it looks like 5. And 0 divided by 5 is 0. So the slope of a horizontal line is always 0. This one, my rise would be, well, in this particular case, it looks like I go up 3. And my run, to go from here to here, well, I don't go anywhere. It's 0. And you cannot have 0 in the denominator of a fraction. So we say that this slope is undefined. So in short, a horizontal line is a slope of 0. A vertical line is a slope that's called undefined. All right, and we'll talk more about what this means later on. So go ahead and pause, and it says, what is the slope of the line through these points? Answers in 3, 2, 1. All right, there's the answer. Hopefully you got those. If not, go back and check your work. Whoops. Let's go. All right, so this sums up kind of some of the things that we talked about. Make sure that you copy this into your notes. First of all, a line with positive slope slants upward from left to right. You read functions or you read graphs left to right. So if it's going uphill left to right, it is positive. If it's going downhill left to right, then it is negative. All right, and it's very important to understand that left to right, because if I look at this one going right to left, it's going uphill. Okay, so in order for understanding the function, just like you'd read a book, we got to go left to right. Read it this way, and you'll see that it goes down. A line with a slope of 0 is horizontal. A line with an undefined slope is vertical. All right, so that's it for today. Nothing too super complicated. We'll look at this more in class, do some practice problems. Have a good day.